Hey guys, Dimitar here. Today is going to be a little bit of a different video. I'm not gonna code, but I'm gonna talk about the. This video is gonna be for people who actually want to become programmers, but don't necessarily know how to go about doing that, even though there's a ton of information online. Or maybe they're not sure. I just want to give you a brief overview, and especially for those of you who are burning to become a programmer, but for some reason cannot get started or are having doubts or something like that. So, the first thing I'm going to cover is the state of programming. As you all know, AI is heavily getting into coding. The turn of events, we all thought it was going to replace um, blue collar jobs, but turns out we're going to replace ourselves. Or will we? So, Claude, maybe you're aware, maybe you're not, Claude, ChatGPT, both of these are pretty good at coding, but it's not 100% sure, even though NVIDIA's CEO will tell you it is. It's not 100% sure they're going to be able to eventually reach a level where you just say, okay, build me an app that does this. And it builds absolutely everything from start to finish and then deploys that, and your job is done as a programmer. I don't think we're ever going to get to that level. I'm skeptical. We could, but we could. Mm, But until then, we're going to need engineers who are able to build modules and then connect these modules. Or at the time of this recording, the AI is good enough to build small modules on its own, and your job is to tell it, okay, build me this small module and connect it to this other module, and then that's how you stack everything on top of each other. Um, so that's the state of programming. So I don't think it's completely dead yet, and I'm not. I don't think it's going to be dead in the next 5 to 10 years, at least. There's always going to be room for good programmers, and emphasis here on the word "good," because yeah, it's there's always room for the best, right? The second point is what it takes to become a programmer. So back in my day, that was 10 years ago when I started learning about programming. Um, there were still a lot of resources out there that one could learn from. And for me personally, what it took was I locked myself into a room for 12 to 16 hours a day, every day, for 5 months. That's the level of dedication it took to go from zero to hero, basically. And that's not an exaggeration. It was literally 5 months of nonstop doing that. Wake up, open the textbook, do the tasks, do the exercises, read, do a project, and go to sleep. That's the level of dedication that is required to become a really, really good programmer. And when I started, at the end of the 5 months, um, I was a full stack developer. I knew how to do front end, knew how to do back end, I knew how to do systems, basically I knew everything. And when I applied for my first jobs, I got all of the interviews, I got offers. So it can be done in a short amount of time. It just requires a lot of dedication. If you're not willing to devote that kind of time every day to programming, it's going to take you a little bit longer. And to be fair with you, you don't really need to go that deep into mastering each subject as I did, because I really delved deep, very deep into everything, and I did a lot of exercises until it became second nature to me. So it's not necessary to spend 5 months, 16 hours a day to become a full stack dev. You can do away with less if you have the right guidance, but you have to want it. Like, you cannot half-ass this. It's only for people who want it. That's going to be who's left at the end when AI takes over and all that. All the programmers are going to be left writing the prompts. It's going to be such people, like the best of the best. Okay. And getting back to the actual things you need to become a programmer. It's obvious, and I'm gonna write it down for you now. So if you have no idea whatsoever how to start, what to do, let me tell you, it doesn't matter what kind of language you pick. The language of choice does not matter. People are going to tell you start with Python. Somebody else is going to start, say, JavaScript, C Sharp, C++. It doesn't matter. It doesn't matter. The first thing you need is you need to learn about variables. Okay, and there are 4 types of variables: text, just regular text, numbers, 1, 2, 3, 3.5, etc. Yes, no type of variables, and dates. These are the only 4 variable types you need to master programming. That's it. That's 4 types. Like, it's pretty self-explanatory. After that, you're going to want to do something with those variables, and then you have to learn about functions. And basically, if you're not good at math, by the way, you don't have to be good at math to do programming. A function is something in. Let me get rid of these arrows because it's going to be less confusing. Something in, something out. That's everything a function is. You give it something, and it gives you something back. It's like a manufacturing line, you know. At the one end, you have parts coming in. On the other end, you have a car. That's basically a function. Classes, and this is optional. Like, many people are going to tell you classes are required. This is, you have to know what classes are. But for example, I don't do classes in my programming when I program nowadays, because I think there are better ways to go about things, so I don't use them. But I do use them sometimes, but very, very sparsely. So a class is just a collection of variables and functions. That's variables and functions in one place. That's a class. That's all it is. And it has a name. And then the 4th thing you need to learn, and you can learn all of these things in a day or 2. It's not that hard to grasp the concept. Like, to master them, it's going to take you a little bit longer. But to get the concepts, to get it down, it's going to take you a few hours, maybe a day. The last thing is control flow. And control flow is all the logic. If statements, for loops, and, return statements. That's it. There are 3 types of statements. You have an if statement. If this, then that. That's an if statement. You have a for loop, which, if you're not a programmer, you're going to have a hard time understanding. But you have, like, let's say 10 apples, and you say, okay, for each apple, do something, or peel this apple, and peel this apple, and peel this apple. That's a for loop. You go through each individual thing in a set of things. And then a return statement, that's probably not even necessary to include here. And that's it. You have 4 things that, if you knew today, you're well on your way to becoming a programmer. Now, this is not everything you need to know to become a full stack developer. Okay? But this is the basics. If you know this, you're good to go. And I forgot something here. There are lists. Basically, this is a list is a variable that contains other variables, if that makes sense. So you could have a list of many numbers. That's the easiest. Like a list of numbers, 1, 2, 3, 4. That's it. Once you master these, you can start building stuff, because these are the building blocks of programming. It doesn't matter what programming language you have. These are the building blocks. And the way I like to think about it is an app, a programming, any app, Facebook, for example, any program is just like a brick wall. And what is a brick wall made of? It's made of bricks. And each individual brick is part of the app. They stack on top of each other. For example, in order to log into Facebook, that's a tiny brick, right? You have a class that's called maybe user, right? And then you have a function within that class that's called login. And when you execute that function, the user gets logged in. I'm simplifying here a bit, But that's basically the gist of it. That's really it. Like you have many such bricks that are stacked on top of each other to become the final app. It's not like one big chunk of text. If that's what you were thinking. So these are the basics. With After you've learned these basics, you actually need to learn a couple of algorithms, and this is where people start getting it wrong. Like, do you want to be a competitive programmer? If you're not familiar, there are people out there who study algorithms very heavily, and they do exercises on that websites like Lead Code. What is there? There's Neat. There's Hacker. What is that? Uh, Logistic Lead Code, right? And there are a lot of different algorithms when it comes to programming, and there are many difficult algorithms. Like when you get a job interview and you go to the interviewer and he says, "Okay, I have," and they give you a task for an exercise to on the whiteboard. Um, Sometimes they're gonna give you really hard algorithms, but to be honest with you, this is only done for companies like Facebook, Google, um, like the big names, right? The FANG companies, Netflix. I can't spell. So if you want to become part of these companies, then yeah, you're going to have to study up on algorithms. But in my experience, knowing a lot of algorithms is not a prerequisite to becoming or to getting a job in programming. It's not required. So having said that, there's a couple of different algorithms you need to know. First of all, you need or concepts. First of all, you need to be familiar with recursion because in your day-to-day job, you will get recursion occasionally, and you have to know how to do that. Okay. And if you don't know what recursion is, don't worry about it. And you also need to know about not need, but not in depth. You just need to be familiar with it, but not in depth. Okay, graphs and the most basic algorithms in graphs, which is DFS and BFS. And to be honest, these are not that difficult. DFS, BFS, these are not difficult algorithms. If you're a beginner, again, don't worry about what these mean. It will get clearer in the future, but for now, just stay. Don't be afraid because you don't have to know that many algorithms to get a job. If that's something that worries you. So if you know all of these four and you know some algorithms, now you're ready to start tackling the how to build apps. Okay. First of all, you're going to need something for the front end. For the front end, basically the internet is built on these three things: HTML, CSS, and JavaScript. And JavaScript is a language. It's not Java, it's called JavaScript. And basically, this is the language of the web, whether you like it or not. Some people don't like it. And HTML, you can pick this up in a day or two. It's not that difficult. It's not a language, it's just the way you structure the web page. CSS, again, this is difficult to master, but with enough practice, a couple of days, you can start getting the hang of it. And JavaScript, well, JavaScript is a programming language, and it has all of these constructs here: variables, functions, classes, and control flow statements. So once you have mastered these, well, the front end part becomes easy because these two, HTML and CSS, they're easy to grasp. Okay, becoming a master, that's a totally different ballgame, but grasping them and knowing how to use them, you can do that in a couple of days. Now, front end, of course, there's a lot of frameworks like React, Next.js, Svelte, Vue, etc. And for today's job market, it's probably your best bet, even if I don't like it, to learn React, because you're going to get familiar with the world of web development. So you have to know React. And React is not a language. React is just JavaScript on steroids. Okay, it's just a framework. But don't worry about these for now. And that's basically it. Like, if you know HTML, CSS, and JavaScript, you can create web pages because you've already mastered these, the core functions here: variables, function, classes, control flow. Now you can easily create a web page. And when you hear the term backend, well, backend relies heavily on these four. Its backend is just programming. So for the backend, you're also going to need to learn databases. That's a fact. And a database, if you don't know, is just like an Excel spreadsheet. If you've worked with Excel or Google Sheet, it's just a collection of rows and columns, and you stick data into that. It's just a glorified Excel sheet. So databases, not that difficult to grasp. To become a master, sure, it takes a longer time, but that's basically it. And here we get to the good stuff. How do programs on the internet talk to each other? Well, you have different protocols, and the most used one out there is called HTTP. It's a protocol. You've probably seen it in your browser. And to use HTTP, or to learn about HTTP, you will have to learn a couple of things which are not that difficult to learn. Sure, in depth, again, difficult, but in general, not that difficult. So you have to learn about getting, posting, deleting, and putting. And these are just verbs of, okay, give me this web page, or please delete this, or please insert this. It's not that difficult. And yeah, HTTP endpoints. Basically, let's say you have Facebook, right? And Facebook can give you access, for example, to maybe you want to see all of the members of a group, for example. Well, you call Facebook's API. An API is just a way for computers to talk to each other, okay? And it's going to use HTTP, for example. I know they use GraphQL and all that, but it doesn't matter. And you say, get all of the posts for this group. And they return it over the wire, over the internet. And once you know this, these are the basics, then you can learn some frameworks. For example, if your language of choice is JavaScript, then if you use JavaScript, JS, then you're going to use Node.js as your server, because it's a standard. There are some others, but the industry, most of it, uses Node.js. And then to make things easier for you, maybe you use Express. Okay. So, and that way your app can communicate with, your backend, the backend of your app can communicate with the front end of your app. And that's it. So once you learn all of these, and I'm not saying it's a tiny amount of information, there's a lot to unpack here, but once you learn about these and you practice them, well, you're a full stack developer. It's not that hard. Variables, functions, classes, control flow. Then you learn the front end, then you do the back end, and then you exercise every day. You do exercises every day. As with anything, you practice, and with enough practice, you will get good. So in a couple of months, you can become a full stack developer. Yes, you'll be a junior one. There will be a lot of situations where you have no idea how to approach a problem, but hey, that's why you have senior developers there to help you, right? Now, after you've learned all this, you're going to need a way to actually deploy your stuff to the internet for the world to use. And the way you do that is two ways. Sorry, not two ways, but There's an easy way and a hard way, and I recommend the hard way because, well, it's better. It's called YAC, which is basically infrastructure, or not YAC, infrastructure as code. Now, this doesn't might not mean anything to you, but basically it says, um, here's a file of all the computers I want. Okay, your app has to run on the computer somewhere, and the infrastructure as code is just a way to specify in a document how many computers you want, how many servers you want, how many databases, and how you want them to connect to each other. And you formalize this in a document. That's all this is. But this is not required. This is optional. You have to learn Docker, and Docker is just a piece of software that pretty much any software developer who's worth their salt knows about, and it's a way to package your application so that it can run anywhere. And then you're going to have to decide, okay, how do I want to deploy my application? Do I want to use my own laptop to do that, to my old laptop so that it runs 24/7, so that it serves content to all the users? You're going to need some sort of server. And there are platforms out there, like you can do VPS, which is not a platform, it's just a concept. You can use Vercel, Netlify, and there's a bunch of others. There's just a way of deploying your project to the internet, okay? And there's solutions that are easy and through solutions that are a little bit more difficult. And here I forgot to mention something very important: cloud, okay? The cloud is everywhere nowadays. And the cloud is just somebody else's computer. For example, in the past, if you wanted to deploy a database, you had to do that on your own servers, on your own machines. Nowadays, if you want to deploy a database, you go to Amazon, not the e-commerce website, but to AWS, which is Amazon Web Services, and you say, please give me a database. You press a button, and they give you back a database. So that's basically a cloud. You can say, give me a computer, and they give you a computer. It's in the cloud, and you can access that from your computer. And the point I'm getting at here, yeah, it's a long-winded way of saying, you also have to learn about the cloud if you want to become a full-stack dev, because chances are when you land a job, you're going to have to use the cloud. There are a bunch of clouds. You have AWS, which is Jeff Bezos's. You have GCP, which is Google. You have Oracle Cloud, which is Larry Payton. I forgot his name. He's a billionaire. You have Ali Cloud, which is a Chinese cloud. And I'm pretty sure I'm missing something here. But yeah, there's like a couple of clouds. But the important thing is, if you want to become a better full stack engineer, you also have to learn about systems. And the way you do systems is, okay, if you're building a single app, you don't need to know much about systems. But chances are, if your app is bigger, or if you're working on a project that is bigger, you will have a lot of moving parts. And this is where software gets complex. It's not just a single file on a single computer. There's 100 computers with 100 moving parts. And for them to communicate with each other, you have to learn about queues. Queues are basically, imagine a supermarket, right? And you have a queue of customers lined up, and the teller is just, the cashier is serving them one by one. This is a queue. You have to learn about containers. There's a bunch of things you have to do with system design. Topics, streaming. These are complex topics, and you can touch on these at the end of everything you've learned. Like, you don't need to learn about that at the beginning because it's not relevant to you. Once you have down the basics, then you can move on to more complex stuff like system design, which is for expert level programmers or seniors. But doesn't hurt to know it, right? And once you get familiar with all of these things, and once you solve enough problems. Trust me, you can become a full stack dev faster than 99% of people, just like I did. And when you start a job, you will hit the ground running. Okay, you will be able to hold your own weight or pull your own weight, um, and you will get promoted pretty quickly because of your skill set. Even though you have zero actual work experience, you've already put the work in. You've already solved like 500 exercises on every topic, right? Because, okay, for example, variables, you're going to have to solve at least 50 exercises to know how to manipulate variables. You have to solve 100 exercises with functions, how to compose them, how to create them, how to stack them together. Classes, again, polymorphism, inheritance, composition. You have to learn about that. But once you drill it into your head, maybe solve 20, 30 exercises, now you know what you're talking about. Control flow, if statements, for loops. It's the same thing. Once you solve enough, like 3 to 4 to 500 exercises doing this, trust me, you will when you join a company, you will be better than most of the software developers there. If you solve enough problems, you will know how to approach every problem, because you've already done it. It's ingrained in your brain. And I think that's it for this video. I think it was comprehensive enough. Um, but yeah, if you have any questions, just shoot them in the comments, and I'll be happy to answer.